Hello to everyone. In this video, let us discuss which one here pH calculation for weak electrolytes. So, if you consider any weak electrolyte, it may not undergo 100% ionization. That means here the given concentration may not be equal to either H plus or OH minus ion concentration produced from that weak acid or base. So one example here, if we consider 0.1 m acetic acid, it is a weak electrolyte. So H plus ion concentration is not equal to 0.1 m because it doesn't undergo 100% ionization. Therefore, for such type of weak electrolytes like weak acids, weak bases, how to calculate H plus concentration and then how to calculate the pH. Let us see in this video. So first, weak electrolytes undergoes a partial dissociation, and that is indicated with a term degree of dissociation. So first let us learn regarding which one here, degree of dissociation indicated with alpha. What is the formula for degree of dissociation here? Molecules ionized divided by number of molecules taken. Number of molecules taken. So this is the formula for which one degree of dissociation. That means 60% degree of dissociation means what? 60 of 100 molecules are dissociated. So like that, for weak electrolytes, degree of dissociation is used to measure the extent of dissociation. And another important one, dissociation constant. What is a dissociation constant? That is which one here? Ka for acid and Kb for base. So for dissociation constant, what is the formula means here? Ka equals to C alpha square. Similarly for bases, dissociation constant also be taken as C alpha square. And some important formulas we have to remember regarding this weak electrolyte concept. So what is that first? If you want to calculate regarding acid, I will write here Ka equals to C alpha square and H plus concentration equals to root Ka into C, or another formula H plus equals to C alpha. These formulas we have to remember regarding which one? Weak acid. Ka equals to C alpha square, where Ka is known as dissociation constant of acid. If Ka value is more extent of dissociation, and if Ka value is less extent of dissociation. And to calculate H plus, the formula is root Ka into C. To calculate H plus, another formula C alpha, where C is the concentration of the given acid, alpha is the degree of dissociation. Similarly, for a base, we have to apply the same concept here. Kb equals to C alpha square. OH minus concentration equals to root over Kb into C, and similarly OH minus concentration equals to C alpha. So these are the formulas we have to use to calculate H plus ion concentration and OH minus ion concentration for which one? Weak electrolytes. Now let us see some questions related to this topic here. So the first question here, degree of dissociation of HCN is 10 power minus 9. Therefore, what is the pH of decimolar HCN solution? What is the pH of decimolar HCN solution? So to calculate pH of the solution, we should know H plus ion concentration. And here Ka and decimolar means concentration given. So now H plus concentration equals to root over Ka into C. That means root over 10 power minus 9 into decimolar means what? 0.1. So we have to write 0.1 means 10 power minus 1, and we get 10 power minus 10, and root over 10 power minus 10 means we get 10 power minus 5. So if H plus concentration 10 power minus 5, therefore pH of this solution is how much? Means 5. So like this we have to calculate pH using that Ka value and concentration. And similarly, regarding a base, let us see this type of questions. Okay, now Ka value, that means acid, but base means we have to give which one? Kb value of NH4OH is 2 into 10 power minus 5. Then its concentration is 0.1 m. Therefore, what is the proton concentration present in NH4OH? Even that is a base, that also should have some proton concentration. We have to calculate which one here? Proton concentration. And also we can calculate pH also. First, to get the H plus concentration, we should know OH minus concentration, because one relation we know that H plus OH minus concentration products is equals to 10 power minus 14. So first, let us calculate OH minus concentration, and using Kb and concentration, OH minus concentration equals to root over Kb into C. That means we have to write here 2 into 10 power minus 5, and okay, let it be the 0.2 m. Okay, now that can be written as, which one? 2 into 10 power minus 1, and we get here 4 into 10 power minus 6. That means 2 into 10 power minus 3. This is which concentration now? OH minus ion concentration. Therefore, to calculate H plus ion concentration, 10 power minus 14 by this OH minus concentration 2 into 10 power minus 3. That means we get 0.5 into 10 power minus 11, or 5 into 10 power minus 12. So this is the proton concentration of this which one? Solution. After getting H plus concentration, we can go for pH calculation also. So now this is regarding which one? Weak electrolyte. When given, how to calculate pH and H plus or OH minus concentrations. Okay, then sometimes they give pH value of any one electrolyte or acid. We have to calculate its H plus ion concentration. How to solve that type of questions? Let us see here. For example, pH of a solution of an acid solution is 5.4. What is its H plus ion concentration? Generally, to get H plus ion concentration, formula is 10 power minus pH. That means 10 power minus 5.4. So how to solve that means we don't know. So how to solve? I will give one easy technique for that. So now let us see, instead of this formula, we have to go for another thing here. pH equals to, we know that they have given how much here, 5.4. One formula in our previous video we have given, which is uploaded on pH, you can observe in that. Again I will repeat here, don't worry. What is that? If H plus concentration is x into 10 power minus y, therefore pH can be written as y minus of log x. Remember this formula. If H plus concentration x into 10 power minus y, pH equals to y minus log x. That means what here? If pH is present in this form, y minus log x form, H plus can be written as x into 10 power minus y. We have to remember these two relations. Now, to calculate H plus ion concentration, they have given pH 5.4. Now let us try to convert this 5.4 as this y minus of log x. So how to write that? To get to 5.4, what we have to do here? Subtract some value from higher integer than 5.4 to get this value. What is higher integer than 5.4 means 6. So 6 minus 0.6. 6 minus 0.6 means we can get which one? 5.4. Now let us try to write 0.6 in the language of logarithm. So we should know logarithm values. Log 1 value 0, log 2 value 0.3010, log 3 value 0.4771, log 4 value 0.6020. That means here 0.6 means that value is approximately near to which one? Log 4, but not exactly log 4 na. So just decrease 0.1 or 0.2 like that. So that means here this can be written as log 3.8. Now compare this with this formula, y minus of log x. This is in this formula. Therefore what is H plus concentration now? We have to write like this, x into 10 power minus y. In place of x, 3.8. So 3.8 into 10 power minus y. In place of y, 6 is there. So 10 power minus 6. So that's it. This is the H plus ion concentration. Like that we have to calculate H plus concentration using pH when they have given like this 5.4 etc. Okay. This is regarding which one? Calculation of pH for weak electrolytes and calculation of H plus concentration using given pH value. Okay, then some other important things let us learn regarding pH. What is that? Dilution effect. So what happens when an acid is diluted or when a base is diluted? Let us see here. We know that 0 to 7, 7 to 14. 0 to 3 is strong acid, 3 to 7 weak acid, 7 is neutral, 7 to 10 weak base, 10 to 14 strong base. So now let us see here. If an acid is diluted, if any strong acid is diluted, what happens? It becomes weak acid. That means strong acid become weak acid means in pH scale we have to move towards the right hand side. That means as dilution increases, pH of acid what happens? Increases. So within the dilution, pH of acids increases. But if you come to bases, now this region is weak base, 10 to 14 is a strong base. If any strong base is diluted, generally that becomes which one? Weak base. That means we are moving in left hand side direction. That means if a base is diluted, its pH value decreases. But if an acid is diluted, its pH value increases. So, for acids, final pH equals to, what is the formula here? Initial pH plus we have to write, because if an acid is diluted its pH value increases, plus log V2 by V1. V2 means final volume, V1 means initial volume. So now let us go for one question in this. What is that? First, uh, 10 ml of HCl has a pH value 3 and it is diluted to 100 ml. What is the pH value? So now final pH equals to, initial pH is how much we have given here? 3. 3 plus log V2 diluted 2. 2 means here final volume 100 ml only. 100 by initial volume 10. That means 3 plus log 10. Log 10 value 1. So that what is that final pH means 3 plus 1 4. So like this we have to calculate. And if a base is given, when base is diluted, what happens? Its pH value decreases. So for a base, final pH equals to, for a base final pH equals to formula initial pH minus log V2 by V1. Here V2 is final volume, V1 is initial volume. Let us go for one question here. 10 ml of NaOH has the pH value 11. It is diluted with 90 ml water. What is its final pH? So now final pH equals to initial pH minus log V2 by V1. Generally, so many students take the V2 value 90 ml, but that is not correct now, because in the previous problem we have given diluted 2, but here we have given diluted with 90 ml. That means 90 ml water added to this 10 ml. Therefore, the final volume is not 90 ml, it is 100 ml, because 10 ml plus 90 ml we have to add now. So now log 100 by 10, that means 11 minus log 10, 11 minus 1 means its pH value is how much? Means 10. So like that we have to calculate which one final pH after dilution for an acid or for a base. Next, and without solving that type of formula, we using that formula, how we have to answer such type of questions? Let us see here. pH equals to, we know the formula, minus log of H plus. So if H plus concentration is 1, H plus value is 1, what is pH value means? Minus log 1 means 0. Then if H plus value is 10, therefore what happens? pH value minus log 10 minus 1. So here we have to observe one thing. What is that? If H plus concentration increased by 10 times, here 1, here 10 is there now. If H plus concentration increased by 10 times, what happens? pH value decreases by 1 unit. Here 10 times, but pH value means 1 unit. So if H plus concentration increased by 10 times, pH value decreases by 1 unit. Similarly, if you consider H plus equals to 100, therefore we get which one? pH value is minus 2. What we can get to pH value? Minus 2. That means here compare the first and third one. 1 to 100 means H plus concentration increased by 100 times. That means pH decreases by 2 units. Similarly, if H plus concentration is 1000, pH value minus 3. Compare the first and third one. If H plus concentration increased by 1000 times, pH value decreases by 3 units. And if you reverse it means if H plus concentration decreased by 1000 times, that means if an acid is diluted by 1000 times, what happens here? pH value increases by 3 units. And similarly, if an acid is diluted by 100 times, pH value increases by 2 units. If an acid is diluted by 10 times, pH value increases by 1 unit. So now, based on this, I will give one question here. What is that? First, 0.1 m HCl is given. 10 ml of 0.1 m HCl diluted to 100 ml. What is its final pH is the question. So now here, let us see how to calculate that one here. So now, first we have to calculate which one pH of this HCl. As H plus concentration 0.1, initial pH is how much means 1 because H plus concentration 10 power minus 1. Now see here 10 ml to 100 ml means 10 tens are 100. That means this acid is diluted by 10 times. If an acid is diluted by 10 times, what happens? Its pH value increases by 1 unit. That means final pH is equals to how much means 2. And similarly, if you come to a base controversial to this, that means if a base is diluted by 10 times, its pH decreases by 1 unit. Here acids in that case increases by 1 unit. But in case of bases decreases by 1 unit. If a base is diluted by 100 times, pH value decreases by 2 units. If a base is diluted by 1000 times, pH value decreases by 3 units. Okay, now another question I give here. What is that? Now pH of A acid is 3 and B acid pH is 4. Now the question is which is a stronger acid means we can tell that pH 3 means stronger acid, B is weaker acid. But how many times they will give the question? So A acid is 10 times stronger than B acid because 1 unit change in pH now we have to tell 10 times. Now if pH given as how much? 5. So acid A is 100 times stronger than acid B because 2 units difference. And in case of bases, for example, A base pH is 9, B base pH is 11. Now we are going in base category, means from 9 to 11 what happens? Basic strength increases. So base B is stronger than base A. But how many times here? Now base B is 2 units difference means we have to tell it as 100 times. So base B is 100 times stronger than base A. So like that we have to give the answers. Okay, this is regarding pH scale. In our next video, let us discuss buffer solutions.